Hello everyone, my name is Pierre Monin, and together with colleagues, we are going to present you KGPrune, a web application to extract subgraphs of interest from Wikidata with analogical pruning. Nowadays, there are more and more knowledge graphs available covering an always widening array of domains. In particular, there exist generic knowledge graphs such as Wikidata, which supports Wikipedia and contains more than 100 million nodes with a large thematic coverage. Given these available knowledge graphs, the existing knowledge is often reused to build new knowledge graphs or support new tasks and applications. However, while doing so, two issues arise. First, manipulating bigger and bigger knowledge graphs entails scalability issues. Second, we need to focus only on relevant knowledge to the tasks or applications at hand and avoid irrelevant knowledge. That is why we propose KGPrune, a web application to extract subgraphs of interest from Wikidata, starting from seed entities provided by users and traversing their neighborhood by following properties of interest also provided by users. Thus, KGPrune expects two input files from users, a CSV file that contains the identifiers of the seed entities of interest, that is to say, key IDs. For example, here we have the QID of Microsoft SharePoint and the QID of the Java programming language, and also a CSV file that contains the identifiers of the properties of interest to traverse, that is to say, PIDs. For example, here we have the PIDs of the instance of and subclass of properties. Note that PIDs can be prefixed by the minus sign for inverse edges to be traversed. However, the neighborhood of seed entities of interest may contain irrelevant entities. For example, starting from Microsoft SharePoint, we end up on dating app, which is not of interest when modeling the IT domain. To prune such irrelevant entities, we rely on analogical reasoning, which is based on quadruples such as Paris is to France as Berlin is to Germany. Here, we rely on known decisions between seed entities of interest and their neighbors and extrapolate these decisions on unknown entities of interest and their neighbors. The known decisions come from a manually annotated dataset that is publicly available, whereas unknown seed entities of interest are provided by users and their neighbors are retrieved by traversing the graph following properties of interest also provided by users. We illustrate our application with two real-world use cases, the first one being the bootstrapping of an enterprise knowledge graph focused on the IT domain, starting from seed entities from the company internal glossary, and the other one being extracting subgraphs related to looted artworks, which requires to handle diverse knowledge such as artworks, genealogy, ownership, and provenance. Users can interact with KGPrune through their web browser or via our API by providing the two CSV files containing the QIDs of seed entities of interest and the PIDs of properties to traverse. These files are sent as a Slurm job onto our computing cluster where Wikidata embeddings and our analogical pruning models are loaded to prune their neighborhoods. Subgraphs are then returned to the users. To illustrate, let us consider the two CSV files previously presented that allow to explore and prune the neighboring classes of Microsoft SharePoint and Java. First, let us upload the two files on KGPrune. When clicking on the Compute button, the Slurm job is submitted to the cluster. Once the pruning and traversal algorithm has stopped, the user can download the list of kept entities as a JSON file or as an RDF subgraph file to be imported into a new KG. The user can also choose to visualize selected subgraphs. In this interface, seed entities are represented in yellow. The user can click on entities to explore their neighbors iteratively. Pruning decisions are represented with a color code. Green entities are kept while red entities are pruned. We are actively developing and extending KGPrune and welcome feedback from the community. Do not hesitate to contact us for questions, use cases, and collaborations. Thank you very much for your attention.